Good afternoon, everyone. I'm Ryan Siegel. I'm joined by my colleague Sean Maurer, and we're here from the Smart Energy Design Assistance Center, housed at the University of Illinois at Urbana-Champaign. Do want to thank everyone for joining us today. Touching on a little bit, what we're going to go through today is understanding some of the differences between the Iecc and Ashrae 90.1, in particular focus on HVAC and service water heating, some of the differences and similarities, along with some of the existing buildings and how that corresponds with that. So if you do have any questions during today's presentation, please go ahead and use the Q&A function that should be towards the bottom of your screen. Uh, so if you do put them in the chat, we might miss them. So go ahead and please do use that Q&A function. If you do have any questions, we may answer them as a course of during our presentation, or may answer them at the end. So today's session is anticipated to be about an hour and a half, and we will provide continuing education credits. We do have ICC as well as AIA credits specifically. Everyone who participates today will receive a certificate of participation. So if you do have another organization that you do self-reporting of continuing education on, that will be available to you. Again, everyone will get a certificate of participation. If you do need ICC or AIA credits, there will be a link in that email that you can follow and provide the appropriate information back to us, and we can go ahead and get those reported for you. So a little bit about who we are. As I mentioned, we're housed at the University of Illinois at Urbana-Champaign, and our primary mission is to reduce the energy footprint of the state of Illinois and beyond. And so energy code training is one of the ways that we work to accomplish that mission. And our training is provided and sponsored by the Illinois State Energy Office, housed at the Illinois Environmental Protection Agency at the IEPA. So we do like to thank them for their sponsorship of this program. Today's session is being recorded, and that recording, along with a PDF of today's slides, will be made available on our website.
Sorry, had someone request to put the slides full screen. Just want to make sure we got that corrected.
There we go. So with that, our next slide here. So part of the training code program is a technical support helpline. So if you do need some technical assistance with the state of Illinois' energy code for any projects you have upcoming or in the process of, feel free to reach out to us, energycode@illinois.edu. If you do have a quick question, where can I find something, you can reach out to us at our 800 number, 800-214-7954. Again, we do encourage the use of that email address, energycode@illinois.edu, just so that way we can provide you a written, thorough response for that. For your question, we do find that several project teams do find this helpful, along as that can provide some written documentation to be shared amongst the project team, along with submission to any code officials that may be involved as well. So that way everyone's reading off the same sheet of music, as it were. We do have several online resources at our website. And so some of those include archived versions of our previous workshops and webinars, along with upcoming workshops and webinars that we have. We also have several online courses. These are online modules that take approximately an hour to an hour and a half to complete. These are available for continuing education credits. So if you do find you are needing some CEUs, this is one place that you can get them. It is designed for more the beginner in mind. So you don't need to be have a real in-depth knowledge of the energy code in order to be able to learn and succeed with those courses. We also do have links back to our technical support helpline. So if you're trying to remember our energy code at illinois.edu address, you can find it through our technical support line there. We also have several other resources, including a little background behind the Illinois Energy Conservation Code, along with some frequently asked questions, along with some information on the upcoming stretch code for the state of Illinois, along with several useful websites. Some of those are links over to the ICC's website for the International Energy Conservation Code, which is the basis of the Illinois Energy Conservation Code, along with links over to the amendments for the state of Illinois and the city of Chicago Energy Conservation Code. So a lot of different, rather than trying to remember those big long strings of characters, you can come over to our website and catch the link back over to that. So we do like to call out that the International Code Council does make all of their codes available for viewing at no cost to you. And the search function is actually fairly robust for that. So you can go through the code book and search the text rather quickly and easily. The Ashrae also has very similar. They do make view-only versions of their standards available at no cost. And so understanding that their most current standards will be at the top of the page, and then further down it will have some of the older versions. So if you do go over to Ashrae's website looking for Ashrae 90.1, understanding that while the 2019 version is the most current version, presently the 2016 version is the one that is referenced by the Iecc presently. And so if you do a search for 90.1, the first one that you're going to come to will likely be the 2019 version. And then if you continue searching further down the page, you'll find the 2016 version. So that's fairly useful as well for those standards. Something else that we do have available is we do have a new set of education modules, our B fundamentals. So this is a 15 different modules. This is designed, again, more for introductory and for new upcoming people in the field. So that's why we call it our fundamentals program. Again, this is available at no charge. And this is a self-paced learning opportunity for you. So again, many educational opportunities out there to go through. Understanding that there are some differences, and part of the reason why there are differences between the Ashrae 90.1 standard and the International Energy Conservation Code is partly how they are developed. Ashrae is a standard, and these standards are able to be used to demonstrate compliance. So you might use Ashrae 90.1 to show compliance with the Illinois Energy Conservation Code. Understanding that the codes are adopted by municipalities and jurisdictions, and they have a separate developmental process from the Ashrae standards. So something we are calling out here is you have to use only one path to demonstrate compliance with the energy code. You're not allowed to cherry pick. So you can't, for example, have an Ashrae 90.1 lighting system with an Iecc, HVAC, or mechanical system. You have to show compliance using one method or the other. You can go ahead and use provisions from the other one, but you do have to demonstrate compliance using only one of these. So you might have, demonstrate compliance using Ashrae 90.1, but there may be some provisions in the IECC that go above and beyond the standards called for in Ashrae 90.1 that you could go ahead and adopt some more rigorous provisions and standards for your project. So understanding we do have several other upcoming workshops. We're covering mechanical today. Next up, we'll be looking at lighting and electrical for the month of April, and in May, looking at performance-based compliance. Another question that we may be coming in here is understanding where the Illinois Energy Conservation Code process is in its transition between the 2018 International Energy Conservation Code as its basis, moving to the 2021 version of the International Energy Conservation Code. That is slated at this point and has been originally proposed to transition for permits beginning June 1st of this year. We do have an upcoming webinar on May 25th, looking at some of these changes from the 2018 IECC up to the 2021 version. So do want to make sure that you are aware of that. So again, that's coming up on May 25th, and we will see if there is updates as far as the adoption of the 2021 IECC in the state of Illinois. We will make sure to also post those to our website. But at the moment, the most current information we have is a June 1st. So projects that have their permit application or have permits issued beginning June 1st would be moving to the 2021 IECC. So being aware that that's coming soon. I mentioned earlier, here in the state of Illinois, you do have two options as far as compliance. You can choose either the 2018 IECC or the 2016 Ashrae 90.1, as the 2016 version is what is being referenced in the 2018 version of the IECC. Again, this will transition to the 2019 Ashrae 90.1 when Illinois moves to the 2021 IECC. So, looking at a little bit about the organization overall, the IECC begins with the purpose and administration, and then goes into the definitions and general requirements. So general requirements, that's where you get your climate zone maps and a few similar provisions. Then it proceeds into the various components and then the code compliance methodologies. So IECC has existing buildings in its own separate chapter 5, which is a little different from Ashrae. Ashrae starts out very similar, purpose and scope, followed by definitions and administration. But then it transitions into our building components and compliance methodologies. Existing buildings are actually built into each of the individual component sections. So if you have you're working on an existing building envelope, that's going to be found in number 5 building envelope. And similarly, Hvac and 6 and so on. Whereas in IECC, existing buildings has their own dedicated chapter. So this is a little bit of a difference between the two. And then understanding with Ashrae that for each section, they break things down a little different, starting with the general and then moving into the compliance paths. So Ashrae calls out, here are the different compliance paths for HVAC. And then depending on which path you choose, do you have the mandatory provisions? You notice here that the simplified approach does not go through the mandatory provisions. However, most of the mandatory provisions found in section 6.4 are also duplicated in the simplified approach. They've just pared down the list of mandatory provisions to those that are particularly focused on the simplified approach equipment. These are generally single zone systems that serve only a handful of square footage, and so talking about the mandatory provisions for large complex control systems isn't really applicable for a simplified approach. So then moving further down, so this kind of follows a very nice flow chart into your different paths from prescriptive and energy cost and Appendix G, which is typically applied for in lead projects, and then finally your submittals and tables and commissioning. So, again here, understanding that the compliance paths really are the driving force and the driving factor behind these rather than the individual components. So, something to be aware of is there are six counties in the state of Illinois that their climate zones are different between Ashrae 90.1, 2016 or 2019, and the 2018 IECC. So if you are in one of these six counties, or your project is in one of these six counties, be aware that that could be a difference for you as you're moving through your project. And this is another many of these differences between Ashrae 90.1 and the IECC that we're going to be going over today. Ashrae or IECC 2021, many of the changes that we saw, many of the amendments for that kind of moved IECC more to be in line with Ashrae 90.1. So again, these six counties and this climate map difference will be going away with the transition of the 2021 IECC. So realizing that there are several differences between these two, I believe we do have a poll question here.
Get that up.
So I want to learn a little bit more about your understanding. And so question one, have you used or seen the Ashrae 90.1 compliance options? Yes or no? And then number two, how comfortable are you with Ashrae 90.1 versus the IECC? Do you definitely know the IECC better, about the same knowledge level for both, or definitely know the Ashrae 90.1 better?
We did have a question come in about why we're comparing the 90.1 2019 with the 2018 IECC. Part of it is we're just kind of covering general overview of the organization of these. When we touch on the actual specific differences, we're highlighting that a lot of these are going to be moving into alignment when we transition to the 2021 IECC. So by looking at the 2019 Ashrae, we're doing a bit of a preview of the 2021 IECC as well. Although we will try to highlight in particular when there are differences that will be coming into alignment and when they're going to be staying different as we move through our presentation.
All right. So looks like most of you have seen or at least are vaguely familiar of the 90.1 compliance option, that it actually is an option for the IECC compliance paths. And looks like most of you definitely are more familiar with IECC. So not that uncommon, but we do like to make people aware that there are different paths and helping to call out where some of those differences are and why you might choose to select a 90.1 compliance for your project versus an IECC compliance. So with that, I'm going to turn it over to Sean to touch on some of the Ashrae.
All right, thank you, Ryan. The first thing we're going to touch on are things that are included in the Ashrae standard that are not in the Iecc code manual. So the first thing we're going to look at is really important for existing buildings. In Ashrae, there are compliance requirements for like replacement. They do allow that in Ashrae for existing buildings. If you remove a system and put the exact same type of system back, then there aren't any upgrade requirements as far as sizing or something like that. Where in the Iecc, when you do replace equipment, even if it is like for like, you do have to do load sizing calculations for that new HVAC system to make sure it's properly sized for the current building loads. So it's a big difference between these two compliance standards for existing buildings. Something to be aware of, like we touched on before, many systems have excess capacity. We've covered in previous presentations. When the opportunity arises for like replacement, sizing that replacement equipment closer to the required load may also reduce some of the additional requirements that may otherwise be required for the original size system. So when you're looking at the Iecc, some of the system components like economizers or heat recovery, ventilation, are based on the size of the equipment. And so if you can downsize the equipment, you can simplify those controls. And so that's an advantage the Iecc has, is that it mandates that proper sizing, where Ashrae can allow you to put in the same sizing equipment. You kind of miss out on that opportunity to simplify your system a little bit. As Ryan touched on earlier, when looking at an overview of the compliance paths for Ashrae, Ashrae does have a simplified path that the Iecc does not. And these will not be added to the Iecc in the 2021 version. So these are exclusive to Ashrae's compliance pathway. But it's unique to Ashrae in that it's taking into consideration if you've got a smaller system and you don't really need to consider all these advanced controls for it. Even with the Iecc, those advanced controls through the regulations and requirements get phased out depending on the size of the system. Ashrae just takes that, separates it out to its own section so it's easier to follow. You don't have to muddle through all the compliance requirements in the full compliance section. But as we noted, this is for small buildings, 2 stories or less. Gross floor area has to be less than 25,000 square feet. And then there are specific compliance requirements detailed in the following section. And so it's 2 pages of compliance checks for the system as compared to the 70 pages for the full HVAC compliance to try to work your way through. So it's a nice addition that Ashrae has put in to try to simplify that reference process when looking up the code requirements. So typically there's going to be single zone HVAC systems. They can have variable flow or multi-stage fan flow if they're above 5 tons in size. Many of these systems are going to qualify given their sizes for this. If we think back to what was mentioned about right sizing equipment, it may help the system meet requirements for the simplified HVAC by reducing its size when you replace it. So just as an example, if you take a 7.5 ton system, properly size that piece of equipment during the upgrade, and it gets reduced to a 5 ton unit, improvements such as lighting upgrade or more efficient computer equipment might help reduce the load in the building so that you can downsize that equipment. So not only is that 5 ton unit going to be less expensive than putting in a 7.5 ton unit, but that new one can use a single stage fan, which saves you even more in your upfront capital costs. And the reduced airflow may also bring the unit under the threshold to require energy recovery. So it's nice that Ashrae breaks this out and lets you consider it as a separate compliance path. It's easier to reference than going through the full compliance options in the 6.4 section of Ashrae. So many of these are good practice. So looking at not having reheat on the system, so you're not having to deal with simultaneous heating or cooling. The system has to be properly scheduled. For hotel motels, it's got those guest room requirements. Piping still has to be insulated, things like that. So these are all just general good practice requirements that the simplified path is working you through. And again, it's just separating them out into an easy to follow pathway. Here's the final list of requirements for that section. While many of these may be common for systems and design, something to call out that we want to note here specific to Ashrae at the moment, and I believe this is getting added in the 2021 IECC, is the final requirement for door switch component. We see this kind of frequently with restaurants. They have overhead doors for one of the walls so they can open up a patio-like area on mild days and have an open air seating area that they can then close off and make an interior part of the building when the weather's not as nice. Something important is if you're going to open up the system to open air, you don't want the HVAC system also running to try to condition that space, because it's just not going to be able to keep up. And that's what that door switch component requirement there is at the end of that. If the doors are open, the HVAC system is going to be triggered to off or to some kind of neutral conditioning temperature where it's not trying to meet full conditioning requirements, minimizing its energy consumption and just doing kind of the bare minimum to meet what the space still needs for ventilation purposes. Ashrae also includes some requirements for ceiling fans of large diameter. So we're looking at fans that are greater than 7 foot blade span here. They have requirements for rated airflow and power at maximum speed. It's a new requirement for large fans. Part of it is to raise awareness for how much power that these can consume and how efficient they are. Frequently, these are only operated at full speed during the summer and at reduced speed during winter to provide destratification in atrium spaces, while minimizing the wind chill factor that might happen in the wintertime. At this time, there's no required efficiency requirement for these systems. So the standard is trying to bring that to attention and put some kind of standard in place. And so having a published span, airflow, and power may enable future efficiency requirements to be established, or just may encourage design teams to select more efficient equipment as they're looking at options for these types of fan systems. For dehumidification, Ashrae has a requirement for mechanical cooling that shall not allow humidity to reduce below a dew point of 55 degrees or a relative humidity of 60% in the coldest zone of a building. The main thing we're looking at here is condensation control and also wintertime humidity control, and not trying to run the system so much that it dries out the building. There are exceptions for specific zones requiring specific humidity levels, such as museums and hospitals, where you want a little bit more humidity in the space. And those zones do have to be approved by the authority having jurisdiction or an accreditation standard. A 10% dead band, so a set point with a plus or minus 5 degree set point for the humidification and dehumidification is part of that requirement. This can be a very energy intense process, so it's good to understand why it's required and how tight that tolerance is. Commonly, the goal for relative humidity is to keep it between 40 and 60%. In the wintertime, though, it's commonly below this range and humidification equipment is required. And so this standard is trying to incorporate that where the IECC doesn't really have this requirement. It allows buildings to dry out a bit more and doesn't really reflect, if you do install a humidification system, the limitations on controls. It kind of leaves that to the designers to build that into the controls. In winter, relative humidity is generally fairly low, so we're going to spend a lot of energy to add that back into buildings. Humidifiers typically require substantial quantities of energy to provide that humidity, so limiting the amount of that energy is a needed requirement. So Ashrae is limiting that relative humidity to 30% in the winter time, so we're not overly humidifying our buildings. Particular concern here is along windows and places where if you get above that 30% relative humidity, now you've got a condensation risk as well. So what we're looking at here is a bit of both energy minimization for that humidification system and building integrity control by limiting that moisture content to something that's reasonably expected not to create condensation on the coldest surfaces in your building. Again, there are allowances for specialty situations such as archives or preservation needs where humidity might need to be a little bit higher for the preservation of certain materials. But again, that requires authority having jurisdiction to provide approval or some accredited documentation. Ashrae has some specific requirements for direct digital controls in several locations where the IECC might allow for just a standard programmable thermostat or similar type of control. And so in Ashrae, this is specifying the minimum requirements that a DDC system must meet. I won't go into all of the specific details as it's quite a long list and we do have limited time here today. But when DDC is required, the system or plant needs to serve at least 3 zones and a fan system brake horsepower of larger than 10 horsepower. For alterations or additions that are adding DDC into those areas, the DDC system does need to cover that new area, or if all the boilers or chillers are replaced, a DDC system needs to be installed if that boiler or chiller replacement is exceeding 300,000 BTUs per hour in capacity. So the system is just essentially laying out if your building's large enough, you need to have DDC controls, and then it lays out the requirements for those control systems. Ashrae also includes chiller plant monitoring. This is not something that's included in the IECC. I believe this may be something that's being added though. So it requires electric and efficiency measurements to be recorded every 15 minutes for a 36-month history at minimum, so that you can monitor the performance of your plant over time. The main thing they're looking at here is that without monitoring that data, you can't catch issues when they arise until it becomes a major concern. So this is looking at maintaining the long-term performance of building energy efficiency with its HVAC systems. Some of this may already be available from onboard controls for new chillers, but the importance is understanding the accessibility of that data, putting it in a central place where operators can see it, make use of that data, and it's not something that just is there and never gets looked at. For campuses and other large facilities that have multiple chillers, understanding which chillers are more efficient at different situations can help optimize those plant processes. So that's the goal of this chiller plant monitoring in Ashrae. Something else that Ashrae includes when you're looking at HVAC control zones, it does have an occupied standby setting in its documentation for the mandatory controls that is not included in the IECC. So zones with auto off lighting controls and 62.1 occupancy allows ventilation to be 0 when in an occupied standby setting for the outdoor airflow. But it shall also set back the heating and cooling set point 1 degree and maintain within that 1 degree so that when the space is occupied, it's readily returned to occupancy conditions. When the space is in the dead band and it's not trying to actively keep the space at set point, then 0 airflow is allowed for that space. So it's taking into consideration spaces aren't occupied constantly through the day. There is some ability for ventilation savings in spaces that aren't occupied consistently. And so as long as those spaces can be readily returned to an occupied state quickly, that's what this condition is setting up. As we noted in some of our previous presentations, the typical minimum deadband that's mandatory in the IECC and Ashrae is a 5-degree deadband between the heating and cooling set points. So with this control setting, it increases that deadband 1 more degree. So you've got a total of 7-degree deadband. And while a 1 degree difference may not make a substantial difference in comfort for the space, it does allow that system airflow to be decreased for a longer period of time, which gives you more savings on the fan energy. And so it's a nice addition that Ashrae has for accounting for variable occupancy in buildings. Ashrae also has requirements for supply temp reheat limits. The reheat limit is not present in the 2018 IECC. Plays a role in both limiting reheat energy and reducing stratification that is normally compensated for with higher airflow in HVAC design. And so here what we're trying to look at with the Ashrae is some guidance on looking at the space temperature and looking at the delivery air temperature. What is the typical design condition that's not going to promote stratification of air delivered to that space, so we can both minimize the airflow going into that space but still maintain comfort while providing reheat to those areas. So as we're noting here, if return openings and supply openings are greater than 6 feet above the floor, the supply temperature shouldn't be more than 20 degrees warmer than the room temperature. And again, it just prevents the potential for stratification where all the heat is trapped up by the ceiling and the actual occupied space of the room down near the floor isn't conditioned properly. Something else that Ashrae takes into consideration for humidification systems. Some of these systems have preheating jackets that preheat the water going into the humidifier. When it's not required, those preheat jackets should be turned off. Kind of seems like an obvious requirement, but you'd be surprised how many times sometimes those things get missed. Preheat coils should stop heat output when mechanical cooling is occurring. Those preheating coils are warming up the air enough that as you're spraying, humidifying it, content into the air, that it can readily evaporate, so it doesn't have a risk of condensing on duct surfaces. And dispersion tube surfaces for those humidifiers should be insulated to at least an R.5. These features make sense as you don't want to add heat to the system when it's not needed, and you want the humidifying heat to stay in the vapor so that when it hits the airstream, it readily evaporates. You don't want it getting cooler in the piping before it gets sprayed into the airstream. So understanding that when humidification is not needed, that source of heat should be turned off so you're not fighting that system for cooling capacity. Similarly, when operating mechanical cooling, preheat coils or freeze protection coils add a false load to the cooling system. We've seen that done for humidity control. They're trying to prevent that here with this requirement. Pipe sizing. Beyond standard pipe sizing practices, Ashrae goes a bit further for sizing chilled water and condenser piping, limits the velocity, limiting the velocity in the piping, as noted here, can limit the pressure drop per foot of pipe. It should be further noted that limiting bends and minimizing the length of pipe will further reduce pressure drop, which may enable smaller pumps to be used for these cooling systems. The photo that we've included here illustrates taking this to kind of a high degree. There's not a single 90-degree bend in this piping system. But the Ashrae requirement here is specifically tuned towards looking at the velocity of flow in that pipe. Again, as velocity increases, the friction rate in the pipe increases and you increase your pumping requirements. Looking at coil selection, previously a 10-degree delta T was common practice for chilled water coils. Ashrae is raising that design criteria to 15 degrees. Again, this is not included in the Iecc. It's still working off that 10-degree original industry standard. This can reduce pumping required as coils can absorb more heat than they can with a 10-degree design. So you're increasing that temperature difference. Additionally, this can reduce the chance of low delta T, which can limit a chiller's output on the return side water flow. When you're designing with that 10-degree difference in your coil on a mild day, you're still sending pretty cold water back to the chiller. That has a serious impact on its overall efficiency. Pressure independent control valves can also improve control of comfort air and further increase the delta T of the coils. And so kind of ways to comply with this design standard. Most chillers capacity is based on a 10-degree differential between supply and return. If there's only a 5-degree difference, which happens in mild conditions with that typical 10-degree design for coils at the air handling units, then a chiller can only put out about 50% of its capacity at rated flow. And so this standard here is taking into account that as we're improving control of systems and we're taking into account more of the part load factors and efficiencies of systems, trying to maintain overall system efficiency. And so requiring that greater temperature difference for the coil design at your air handler is helping to improve that part load performance of your systems at the central plant. There are some exceptions for the application of this. If you have a constant air volume system that's smaller than 5,000 CFM, and some other less common applications for the system. We won't get into all the details here. Ashrae also has specific requirements for high capacity space heating. Most new large boilers are condensing type boilers. The issue we run into these is if the return temperature is too high for water coming back to the boiler, they can't operate in their condensing range and their efficiency is lost. And you essentially have a non-condensing boiler's operating efficiency, maxing out at about 85% for a system that's rated to have somewhere between 95 to 96% efficiency. So the chart we've included here just kind of shows that efficiency change with the return water temperature at a 30-degree Fahrenheit temperature rise in the boiler. And so what Ashrae has included here are requirements for the design of the system where the return water temperature is going to be limited to a temperature that's going to allow condensing to happen at the boiler still. So these are kind of things that are good practice that Ashrae is kind of mandating now, where the Iecc is allowing those things to remain as standard practice, but isn't really mandating them yet. For exhaust air energy recovery, Ashrae does have similar requirements to the Iecc for the most part, but Ashrae also has some requirements for non-transient dwellings, including needing 60% enthalpy recovery ratio for the winter design condition. That's the big difference here between Ashrae and the Iecc's energy recovery systems. There are a lot of different ways to achieve that 60% enthalpy recovery. Heat wheels are the most likely in commercial buildings as compared to a static core that's found in a lot of residential applications. It has a little bit lower efficiency ratio typically. So this Ashrae requirement may start seeing with Ashrae compliance a little bit more proliferation of energy wheels into residential and long-term dwelling requirements. For surface water heating, Ashrae is looking at recovering condenser heat for surface water heating from HVAC chiller systems. Surface water heating energy recovery is not required too often, as that 1 million BTU per hour water heatings, that's a lot of service hot water. It's going to be a pretty big building. Additionally, there's that requirement that the facility operate 24 hours per day. So this is probably going to apply to more like hospitals, larger facilities with 24-hour occupancy. It's a pretty limited application. One might also consider using heat pumps, either as a air source or a water source heat pump system to do this kind of recovery. But Ashrae, again, is trying to incorporate some of these standards for larger facilities that are kind of typical best practice in the industry, and is trying to advance those best practices through standard implementation. Space conditioning heat recovery. Ashrae includes condenser heat recovery. We're looking at heat recovery chillers here for large systems that have simultaneous heating and cooling needs. So you're looking at providing low-cost heating or low-cost cooling, depending on your perspective and what the core base load is. And so that condenser heat recovery is supposed to supply 7% of your cooling capacity for inpatient hospitals operating 24/7. They typically have a large cooling capacity 24/7 of the year just because of all the equipment and occupancy in those spaces. Design chilled water capacity of 3.6 million BTUs per hour and simultaneous heating and cooling that occurs above 60 degrees Fahrenheit outdoor air temperature. So you're looking at reheat there essentially. And so in that situation where you've got lighter cooling loads, you can recover some of the heat off of your cooling system to provide your reheat loads for the building rather than trying to generate that reheat separately. Ashrae also has some requirements for pool dehumidification. It's one of those areas that requires a lot of energy and can also increase chemical use if humidity is driven too low. So Ashrae does require energy recovery at a fairly low threshold of only 500 square feet. It's likely that designs will select the first method listed here of exhaust sensible recovery or total energy recovery of at least 50%. Because it's kind of difficult to connect a condenser to the pool heating system. But it is possible to also do condenser heat recovery off of the pool system or the heat exchanger system and use that to provide heating for the pool when it's needed. For door switches, we touched on this earlier in the simplified requirements section. Here it is in the mandatory requirements in the full section. For conditioned space with a door that opens to the outdoors, it shall be provided with controls that when the door is open, you either disable the heating or lower the set point to 55 degrees, disable the cooling or raise that set point to 90 degrees. And this excludes entries with automatic closing devices. So your typical vestibule entries. Again, this is the criteria that's looking at if you're designing into a building a space that's alternately an open patio in mild weather and an enclosed portion of the building during more inclement weather, that you're providing a neutral conditioning from the air conditioning system if it's active, or just completely disabling it to minimize that energy consumption and prevent waste just of conditioned air going out those open patio entries. For IT closets, Ashrae has a standard for design, has a standard for data centers that is not included in the IECC currently. It's triggered once a computer room has more than 10 kilowatts of IT equipment. It's good to understand where the threshold room is, where the threshold is between a room with IT equipment and a data center. Buildings commonly have several IT equipment rooms with lower loads. And so that transition to a data center that has specific requirements in Ashrae 90.4 is that 10 kilowatt total power requirement. Duct insulation for the most part matches the IECC. R6 for interior ducts, R8 for exterior ducts, or R12, depending on the climate zone. As Ashrae includes directly conditioned spaces, there is a separate insulation, indirectly conditioned spaces, sorry. There is a separate insulation requirement in Ashrae of R1.9 for ducts in those indirectly conditioned areas. This might be semi-conditioned, semi-heated spaces that again, the IECC either considers spaces as fully conditioned or unconditioned. So here they're looking at return duct insulation isn't required in those spaces because there's not a great temperature difference there. If the return is pulling air from a plenum space or indirectly conditioned space, there shouldn't be any temperature difference there. But on the supply side, you do need to have at least that R1.9. The duct insulation is helpful for preventing condensation and rust on the ducts, so it maintains the longevity of the system, and you're reducing the heat loss from conditioned air to this semi-conditioned space. I did have a request here real quick for the door switch control. Someone wanted me to show that again. So before I move on, we'll jump back to that screen. So again here, in Ashrae, it's not yet implemented in the IECC. If you're going to have a space that's seasonally allowed to be an outdoor space, then you have to have the ability to either disable the heating and cooling system or turn those set points back to a neutral set point to minimize energy consumption. And I think we'll pause here for a poll question. And our first question is, for a 4-story above grade building, 25,000 square foot, can it use the simplified HVAC approach, true or false? How far back must chiller plant monitoring data extend to comply with the 90.1 requirements? Let that poll run for a few minutes. I don't see any questions in the Q&A. don't see any have popped up in the chat either. Again, if you do have questions, please drop them in that Q&A window. Give it a couple more seconds here. We've got a few more responses trickling in. Okay, go ahead and share those results. Most people got this correct. A two-story building in this situation would be able to use the simplified approach. Four-story is too tall to qualify for that simplified HVAC approach. It has to be 2 stories, less than 25,000 square foot to use that simplified approach. And then chiller plant monitoring data needs to go back 36 months. That would be 3 years. So looks like most people got that. A few people thought it was a few months less, but about a year less. But yes, it does need to be 36 months, 3 years. So with that, I will hand it back to Ryan to cover kind of the direct comparisons between Ashrae and IECC where they have similar requirements.
Well, thank you. So yeah, these are going to be provisions that are found in both and may have similar or even identical requirements. And so here, understanding that when you have an addition onto an existing building, but you're going to serve it from existing equipment, Ashrae and IECC do allow basically grandfathering that equipment in. So if you are extending HVAC equipment and ductwork to serve an addition, you don't have to upgrade those systems in order to comply. But if you are putting in a new system, then it does need to comply with the new requirements. So this can be kind of handy, as Sean alluded to earlier, that oftentimes we find HVAC equipment does have reserve capacity remaining on it, either from initial oversizing or perhaps upgrades that have been made throughout the building, lighting and plug loads that now have some reserve capacity that can be extended. So it's kind of nice that they don't require, if you're going to extend that ductwork, to go ahead and upgrade your HVAC unit. They say, no, it's your existing one is fine. Just, go ahead and, make sure your ductwork is good. So, and also they have a lot of similarities in their setback requirements. We definitely need to make sure that we do have at least one thermostat control per zone. And Sean mentioned the 5-degree deadband goes up to 7 if you're having a system that goes occupied standby, programmable thermostats and setbacks and zone isolation. So again, this is the same across both Ashrae and IECC. One area that's substantially different is the setback temperature, where Ashrae specifies, a 10-degree heating setback on the heating side and a 5-degree cooling setback. Ashrae also does have a little provision in there if you are using a radiant system to only set it back 4 degrees instead of 10 degrees. And a lot of that is because radiant systems don't respond as quickly. And as a side benefit is radiant systems oftentimes are allow the systems to operate effectively, typically at a little bit of a lower set point too. So, having that smaller setback from that lower set point makes a little sense. IECC, however, requires the setback on the heating side to go back to 55 and the cooling to go up to 85. So that's rather dramatic setups and setbacks. If you figure your typical temperatures are perhaps going to be somewhere around the 70 heating and 75 cooling, So that's going to be like a 15-degree heating setback and a 10-degree cooling setback. So rather dramatic difference there. Understanding that how the setback options work, Ashrae, they have setback requirements separate from a shutdown, and the shutdown requirements kind of go back to as far as when you reactivate the system is going back to either occupant sensor controls, a manual timer. So if you have a cleaning crew come in, they can go ahead and turn on the system with a 2-hour limit on that, or interlocking with the security systems, understanding that more and more buildings these days have integrated building automation and building security systems. So badging systems where someone's going to badge in and badge out, so the system can actually keep track of who's in and who's out at any given point. The Iecc just kind of lumps it all together and has the various requirements as far as what that time clock or programming controls has to have. So a little bit of difference there. Optimum Start. Ashrae gives you a few different methods for this, understanding that you'd have to monitor these things in order to understand and provide that optimum start controls, whereas the Iecc is a little bit more vague and just says, hey, you need to be able to adjust that timing so that it's able to achieve the desired temperature by the time you schedule occupancy. So again, that's where Ashrae, being a standard, is much more specific about here is what you need to measure such that the system has the ability to achieve the desired result. Iecc just says here's the desired result, figure out how to do it. So this is where, as you're going through, it may be very beneficial to understand the Ashrae 90.1 and Iecc. So even if you're using Iecc as the compliance path, Ashrae can give you some clues as far as how to achieve that. So motorized damper leakage. This is another one where Iecc just has one standard that covers both climate zones 4 and 5 here in the state of Illinois. Ashrae kind of has a little split in here. So the warmer south portion of the state of Illinois can allow leakage of up to 10 cubic feet a minute per square foot of area during the standard test procedures. Whereas if you're in the colder climate zone 5 towards the northern part of Illinois, that's going to be the 4 CFM per square foot. So parking garage ventilation. So here it's a little bit similar in that Ashrae and Iecc both allow for the 50% stage and modulation. Iecc adds another option rather than staging or modulating to intermittently operate the systems for that. So also for ventilation, Ashrae does have an exception for smaller square feet or ventilation that has high performance or high efficiency. So it's able to cover up to over 1,500 square foot per horsepower, and with no mechanical heating or cooling, then you don't have to do the demand controlled ventilation. Whereas Iecc sets that target at least 1,125 CFM per horsepower. So the Ashrae standard is a little bit more strict at 1,500 CFM per horsepower. And so while Iecc has a little bit lower efficiency standard, it does have a little bit more stringent as far as the exception. It's based on CFM rather than square footage of that. So little bit of a difference there. And when you're getting into demand controlled ventilation, so here we're looking at inside buildings rather than parking garages where we were before. So if we've got Ashrae, we see here the design airflow is set much lower at 750 CFM versus IECC. The threshold is 1200 CFM before you trigger DCV. And then as you're Ashrae looking at, there is something, a provision where if you have more than 75% of outdoor air is being done through transfer air or being provided through to other spaces for makeup air, then you can avoid needing DCV. Probably a common location that we'd see this would be places with large exhaust rates, laboratories, restaurants would be a big one, where you've got that kitchen ventilation rate that you have to be providing a lot of makeup air. So here, where commonly we'll see restaurants, they're going to go ahead and put the makeup air uh, or use the dining room for that makeup air and transfer it through into the kitchen. So that's one area that we would commonly see that DCV exception used. And IECC kind of phrases that a little bit differently, looking at what is the differential between the supply and the transfer air being under 1200 CFM and process loads being directly excluded for IECC. Ashrae, it gets into the occupancy categories rather than the specific uses. The Economizer exception, Ashrae does have two exceptions for both climate zones 4 and 5, whereas IECC only has an exception for climate zone 4. So while Ashrae does have, exceptions for both 4 and 5, it does have a much higher threshold. So, I mean, understanding you got to be able to increase your cooling efficiency, by 42 or 49%, that's a dramatic increase. Whereas the IECC just says, hey, as long as you're up to 20% better, that gets you past that threshold. So one of the other different substantial differences, and again, this will be a change, an upcoming change in the IECC, is Ashrae has updated to using the fan efficiency index, whereas IECC uses the more legacy fan efficiency grade. The fan efficiency index takes into account, things such as the motor that's being used, the drive, it's looking at the total system efficiency and trying to encourage selection of equipment with high efficiency relative to its potential. Whereas the fan efficiency grade is more looking at just the fan itself and what is the efficiency of that fan. And so understanding that the Ashrae, you're trying to get to a target of 1.0 or higher, whereas the IECC is a 67 grade of 67 or higher. So that's kind of a 67% efficiency of the fan versus the system efficiency, saying, hey, we want to be at or better than a relative point. So they also treat hot gas bypass a little bit differently. Ashrae limits it as much more restrictive as far as hot gas bypass. Ashrae is limiting it to 15% or even 10% if you're getting into these larger systems, over 20 tons. IECC is much less restrictive. It gives you 50% up to 20 tons of cooling and 25% if you're above that. This is something that again, we're seeing more and more equipment efficiency, equipment manufacturers trying to reduce how much they use hot gas bypass for capacity control. and trying to use alternate methods. And some of this is also, as we're seeing more variable speed compressors and much more variable refrigerant flow systems going in, they have much better capacity control rather than just using hot gas bypass. Because really what you're doing is you're just giving up some of that work that you did to compress that refrigerant and then just releasing it is not terribly beneficial. Well, variable flow controls, again, this is a little bit different. Ashrae says if you got at least 3 control valves, then you need to have variable flow. Whereas IECC bases it on the size of the system. So if your hydronic system is over, 300,000 BTUs, then you have to do variable flow. So regardless of if that's, several small systems or, just a couple of large systems. So a little bit different methodology here. Whereas Ashrae is saying, hey, if you got at least 3 zones, yeah, let's do variable flow for that, which also is being aided by that delta T, that of 15 degrees, really trying to lean on that and get better performance over the whole system. So with that, I believe we've got another poll.
We do.
And it is, what are the 2 main differences in the setback requirements for Ashrae 90.1 and IECC? Ashrae has more relaxed setback temperatures. Ashrae splits the setback and shut down, where IECC lumps them together. Ashrae has a square footage minimum, not in the IECC, or Ashrae has a CFM missing from the IECC. And then the second question, Ashrae and IECC system efficiency exceptions for economizers. Again, looking at that economizer exception, apply to both climate zones 4 and 5 in Illinois. So is this true or false? So the second question, are they the same or are they different between that for the economizer?
We had a few questions come in. One on the door switch controls for a garage receiving space. Would a unit heater need to have that door switch control, or is that only a seasonal operation requirement? So it depends. If that door is a manual door that could be left open, then you would have to have the control. If it's an automatically closed door that we see in a lot of like auto repair centers and things, you drive your car in, the door closes behind you, those would not have to have the door switch controls. So it depends on whether that door is automatic close or manual. And Ryan, back to your discussion of building additions and not having to update the HVAC system. We had a question come in, what if you're just replacing the HVAC equipment with Leakage? And I think we touched on that earlier in my section, the big difference between Ashrae and IECC.
Yeah, the important thing there is if this is being dealt with for an addition, then if you're replacing the HVAC unit, then you're in that requirements for what are the requirements for replacing an HVAC unit? If it is like for like and you are using Ashrae 90.1, then you're able to just do that replacement like for like. If it's IECC, then you do have to go ahead and make those improvements. And as Sean mentioned earlier, good practice, again, because we see many of these HVAC systems, what has changed over the last 15 years or 20 years of a building. You might consider doing a load calc, even if it's not necessarily required, just from the perspective of you might be able to downsize the unit, which may save you some equipment and labor costs to do that install and make that upgrade, plus better comfort, better control, and potentially lower utility bills. So, all right. So our poll questions, the 2 main differences is, yes, Ashrae has the more relaxed setback temperatures, and Ashrae splits the setback and shutdown. So the first two are the correct answers here. Looks like most people picked up on that. And then Ashrae and IECC system exceptions. This is a false statement. This is where there's a difference between Ashrae and IECC for economizers. Ashrae has exceptions for both 4 and 5. IECC is for climate zones 4 only. So
Before we move on, we did have one more question. Does HVAC equipment using R22 refrigerant, is that still acceptable in the 2021 IECC?
yeah, the IECC and Ashrae 90.1 are refrigerant agnostic. There's nothing that precludes use of R22 refrigerant equipment. Most all R22 equipment is legacy equipment. But there's, if you have good equipment that continues to operate, and there's no need to replace it, there's nothing wrong with, there's nothing wrong with keeping things going. But yeah, the codes do not touch on which type of refrigerant, understanding that the flavor of the day today versus next year will be different.
Okay. We'll go into service water heating differences, comparing Ashrae and IECC here to wrap up our presentation. So first thing is service water heating load calculations. Similar to building HVAC, it's important to properly size your surface water heating equipment. So Ashrae has included a requirement for that. That equipment shall be sized per the manufacturer's published guidelines, an engineering standard, and handbook, or other calculation method acceptable to your authority having jurisdiction. For facilities such as what we've got pictured on the screen here, where you've got multiple storage tanks, you could try, if you need to reduce size, isolating a tank, isolating one or more of those tanks to see if all the tanks are still required based on the current operations and loads in the building for the given water consumption. Commonly with new fixtures where less water is used at each fixture, your hot water capacity has been reduced over time. So particularly in existing buildings when looking at upgrades, Ashrae does require that the domestic water system be properly sized. This is excluded from the IECC currently. So in the example we've got on screen, if they find only one tank is needed, they could choose to place one of these tanks into long-term storage, use it as a backup later when the one in use fails, or they may choose to continue to operate both until one fails, then go down to one and not replace the failed unit to meet that sizing capacity. Alternatively, they may find that one meets the needs most of the time except for peak times. This allows for options to further adjust loads so that one tank can handle loads, or downsize the existing tanks when time for replacement, such as moving from a pair of 100-gallon tanks down to a pair of 75-gallon tanks. Again, just noting that the efficient operation of systems, looking at cycling rates and things, you want to make sure that it's properly sized. You don't have a short cycle situation that's going to end up wasting a lot of energy, particularly with gas units where you've got a purge cycle to your water heating before the combustion chamber fires. You can lose a lot of heat capacity out of your system that way. So this is looking at, just as with building systems, maintaining that optimal operation based on your design loading rates and maintaining that long-term efficiency of that system. For service water heating temperature limits, Ashrae does specify some fairly strict limits on service water heating that not only save energy, but reduces the potential for scalding injuries from use of overheated water. Facilities with at-risk populations may need to run higher temperatures in their tanks to prevent Legionnaire's disease, and then have mixing valves or something on the distribution system to then meet these set point requirements. And so for Ashrae, they do specify that 120 Fahrenheit or lower is needed for the intended use, and then 110 Fahrenheit for public lavatories, hand washing stations, essentially. For temperature maintenance controls of service hot water systems, both Ashrae and the IECC have requirements for time switch controls. However, Ashrae only specifies that time switches or other automatic controls need to turn the system on and off when hot water is not required. The IECC is much more stringent in that it requires an indication of demand in the system to turn the pump on, and then turn it off once the line has reached its set point and has been charged back to temperature. So we've talked about this a lot in the past with the IECC, but the Ashrae does have a more relaxed requirement here, in that time switches are allowed for compliance, where you could set up a building with a regular usage schedule, cycle the hot water when the building's occupied, and turn that off overnight when no one is in the facility. Slight differences in the pool cover requirements here as well. Ashrae requires pool covers for heated pools indoors and outdoors, where the IECC's applies to outdoor heated pools only. Pools heated above 90 Fahrenheit must have a cover of R12 or better, unless 60% of that energy is from recovered energy for Ashrae. IECC's, again, a little bit more stringent in the energy recovery requirement of 75%. But again, only for outdoor pools, not really considering the indoor condition. For warmer pools, such as therapy pools that cover may have an increased insulation value, so we're looking at the R12 there for Ashrae. IECC doesn't specify an insulation value for that pool cover requirement. It's mainly focused on that reducing evaporation losses. Shared equipment. Ashrae prefers to avoid sharing heating equipment between space heating and service water heating. So there are some provisions here that do allow that under certain situations of low standby losses, demonstrated savings over having them as separate units, and limited capacity. The IECC does not include these kind of provisions. They are usually separate systems. So we commonly see this in heating systems that use boilers that may contain a domestic water generating coil that then exchanges heat with a nearby storage tank. Sometimes see this with high-rise buildings with boiler systems. The primary reason to avoid bringing on the whole boiler to serve just the service water is that it doesn't match the load of that boiler. And so it's going to operate at a very inefficient way. And so by limiting the size of that system, capacity, you're more likely to be closer to the design operating point of that boiler system when operating it for service water loads. Something that the IECC includes that Ashrae does not, kind of a rare exception here, where Ashrae has a requirement that's not in, IECC has a requirement that's not in Ashrae, is the heated pipe length requirements in the IECC. So we do have a supply volume limit for public lavatories of 2 ounces, and for all other domestic hot water uses of about a ½ gallon. And these factor into also the pipe length requirements from the heat source to the water fixtures. So as we can see, this requirement either requires point of use heaters or a temperature maintenance or circulating system in most commercial buildings. It's very rare that you're going to be able to have a water system at a central location distributing out to remote rooms that's going to be under 2 ounces or a ½ gallon. So with the newer ½ gallon per minute faucet aerators, something to note here is that the flow rate's only about 1 ounce per second. So with a seemingly minute 2 ounce allotment, it's still 2 seconds from when the tap is turned on before hot water arrives. If that doesn't seem long in your head, I could pause for 2 seconds here and we'll see how long that feels, but we'll keep moving along. And then some specific notes for existing buildings for service water systems. In Ashrae and Iecc, replacement equipment needs to meet the same requirements as new construction without requiring alteration to building systems outside the scope of that alteration. So we touch on load calculations here, economizers, demand control ventilation, similarly for service water heating systems. So we do have one final poll here to launch, and we'll answer any further questions that have come in. Our poll question, Ashrae has more specific service water requirements in which areas? Load calculations, temperature controls, pool covers, or pipe length? This is a multiple choice answer, so select all that apply. We did have a question come in. What have you typically seen used to satisfy the Iecc requirements for demand control on recirc pump controls? Ryan, you've done a couple presentations on this. You want to touch on that?
Yeah, the three common methods that we have seen used for pump controls for domestic hot water for Iecc have been a flow switch on the cold water inlet to the hot water tank, a occupant sensor, or a user interactive low voltage push button. I believe we see the low voltage push button commonly in residential applications, where it's normally in a master bedroom that's on the far end of the building. The little pump sits underneath the vanity, and there's a little button on the side to say, hey, I'm going to need hot water soon, prime the line. Probably for commercial, the most common is probably going to be the flow switch on the cold water inlet, as the only time that would trip is if hot water is being drawn out of the hot water loop, because what you need to avoid is just the flow running through that loop from triggering that flow switch. So yeah, that's where it's on the cold water inlet of the system.
Okay, looks like we've got most of our responses in for our poll. Looks like most people have picked up that Ashrae is more stringent on service water heating requirements for load calculations and temperature controls. Pool covers is a little iffy, although we tend to lean towards Ashrae since it requires both indoor and outdoor pool covers, even if the temperature requirements are a little bit different, a little less stringent. But pipe length is more stringent in the Iecc. Ashrae does not have those pipe length provisions in them where the Iecc does. So the first three there are the correct choices. The last one there is the Iecc is more stringent. I don't see any other questions that have come into the Q&A or the chat. So we'd like to thank everyone for joining us today. If you do have any further questions or need some detailed response, please feel free to email us at the address on the screen there, energycode@illinois.edu, and we'll get back to you as quickly as we can. Thank you for joining us today. We hope you have a wonderful afternoon.